Here we go. Kindly confirm whether my computer screen it is visible or not. Okay. Is my computer screen visible to you?
Yes, sir.
Okay. Any audio related or voice related issue, feel free to let me know that. Okay. So once again, good morning to everyone. And let me welcome you all to today's numerical aptitude session. And today we are going to discuss questions from solids, that is mensuration. So let us get into the first question. I want you all to consider this first question, read it properly, and then listen to the explanations. All right. So please read the first question. I will explain this. Okay, how to do this question. That part I will anyway explain to you. Just listen to this. So you are considering 1 square kilometer of land area. It means you can consider something like this: 1 kilometer length and 1 kilometer breadth. Okay, 1 kilometer square area. Is it clear to you? 1 kilometer square of land. Rainfall happens in this 1 square kilometer area, and it is given that it corresponds to 1 centimeter of rain. It means that here, when the rainfall happened, the water level, okay, if you consider it, it was actually 1 centimeter height. That is what it means. Okay, when I say that 1 centimeter rain, it fall on this area 1 square kilometer, it has to be perceived like this. In this area, 1 square kilometer rainfall it happened, and because of the rainfall, 1 centimeter height water level, there was water logging. Like that, you can assume. Okay. Now, if you are looking at this diagram, it will give you the idea. Okay. Now, let us find out what is the volume of rainfall it has happened in this area. So you know volume, it is equal to length into breadth into height. Correct? Base area into height. So the volume of water that actually fell in this place, that corresponds to 1 kilometer into 1 kilometer into 1 centimeter. Got it? And I can see that this corresponds to 1 kilometer. How many meters? Can anyone unmute and tell me? 1 kilometer, how many meters?
1000.
1000 meters into, again, 1000 meters into, 1 centimeter. It corresponds to 0.01 meter. Okay, so this is the total volume of rainfall it happened in this area. So we can see that after this rainfall, it has happened 50% of the raindrops, they could be collected and it could be directed to a pool. Okay, so 50% means half of this total rainfall it happened. 50% of the raindrops could be collected means half of this water collected, it could be guided to a pool. Okay, so I can see that the volume of water that is guided to the pool, it will be 1000 meter into 1000 meter into 0.01. It's half divided by 2. This is what is guided to the pool. Okay. Now you can see that here, this pool, it has got the base area. If you consider 100 meter into 10 meter. Now, by what level? The water level in this pool, it increased. That is the question. So, the height of that water level that is there in the pool, if you want to find out, it is enough to find what is the effective volume of the water that was actually guided to the pool. That can be equated to this base area 100 into 10 into some h meters of height, the water actually rose in that pool, increased in that pool. Is it clear to you? So 1000 into 0.01 by 2, it is guided to the pool, and that volume will be nothing but 100 into 10 into h meters. That is the level by which the water level in the water pool, it actually increased. I'm taking it as h. So now just by calculating this, you will be able to get the value for h. So you can see 1000 into 10, sorry, 100 into 10, it is 1000. We can cancel 1000 here. And you can see here, it comes to 500. And 500 into 0.01, it is equal to 5. And this gets you h, it is equal to 5 meters. I can thus conclude that the water level in the pool that it got collected because of this rainfall, it corresponds to 5 meters. And that is the increase in the water level that happened in the pool. So h equal to 5 meter, that is the answer for our question. Is this explanation clear to you? Any doubt? Have I explained it clearly to you? Please unmute and let me know. One or two of you.
Yes, sir.
Okay. Now I am presenting the next question here. Is it possible? Are you getting the second question on the screen now?
Yes, sir.
Yes, sir.
Okay.
Sir.
So, yeah.
Sir, do we have to submit the worksheet today?
No. No.
Okay,
it's
sir.
not required. When I say it's not required, it doesn't mean that you are free to do something else. This is an important topic. Okay.
Yeah, okay.
Fine. So let us discuss this. Question 12. Look at this. Find what length of canvas 2 meters wide it is required to make a conical tent 8 meters in diameter and 5.6 meters slant height. Okay, so you are using this canvas to make this tent, correct? Conical tent. So the area of the canvas required is nothing but the curved surface area of this conical tent, not the base. We are only focusing on the side, that is the curved surface alone. So you should be focusing and trying to find the curved surface area of this given cone. Okay, so what is the expression, the formula to find the curved surface area of a cone? Curved surface area of a cone is pi r L, where r it is the radius and L it is the slant height. So if you look at a cone here, we can see that this is the radius and this is the slant height L. The curved surface area, that is the area pertaining to this curved surface here. If you consider this, it will be nothing but pi r L. So let us do the calculation here. We can see that curved surface area is pi r L. Radius, it is equal to 4 meters. The slant height, it is given to be 5.6 meters. And this gets me the curved surface area. It is equal to pi r L, that is 22 by 7 into radius 4 into slant height 5.6. This is the curved surface area. So this is the area of this rectangular canvas that you are considering. Let us consider the length of the canvas. Let it be some L meters. Its width it is given to be 2 meters in the question. So this length into width, it gives you the area of the canvas. And the area of the canvas is nothing but the curved surface area of this cone. That is 22 by 7 into 4 into 5.6. Now from this calculation, I can get the value for L. And L, it comes to how much? You can see pi into 4 into 5.6 whole divided by 2. That's what we have to do. So from this, I can get the value for L, the curved surface area. And can you know what will be the value here? From this curved surface area, can you tell me what is the value for L? Okay, it will come to 35.2 meters. You are finding the length now, length of this canvas, that is equal to 35.2 meters. So we got one answer. Now, it is given that the cost of this canvas, it is rupees 2.8 per meter. So 1 meter, the cost is rupees 2.8. Like that, you have to consider 35.2 meters of length. So 2.8 into 35.2, it is going to give you the cost associated, and that comes to rupees 98.56, and that is the answer for our second part of the question. Okay, so pi RL you have to remember, and from that you can get the length, and from length you can now find the cost. 98.56 is the answer. All right. Let us now consider the next question. I assume the next question, it is visible on the screen, right? Yes or no? One of you please confirm. Can you see the next question?
Yes, sir.
Okay. Here you are considering a cylinder. This cylinder, it has got radius. It is given to be 6 centimeters. So from the center to the side, if you consider, you can see it is 6 centimeter radius, and it is given that the height, it corresponds to how much? As you can see, the height, it is 28 centimeters. Okay, so we can see that these are the mathematical units: 28 centimeter height and 6 centimeter radius. You are getting a cylinder now. Now, you are making some spherical bullets from this cylinder. You are melting this cylinder, and from this cylinder, you are actually making some spherical bullets. So, the volume of the sphere, it is nothing but 4 by 3 pi r cube. This is going to be the volume of one bullet. Like that, let us consider n bullets are being made. So the total volume, if you calculate, it will come to 4 by 3 pi r cube into n. This total volume will be what? Can anyone tell me? This total volume will be the volume of the cylinder. And the volume of the cylinder is nothing but pi into r square into h. Here the radius, it is 6. So radius square into height, that is equal to 28. So you can see the volume of the cylinder, it is given by pi r square h. So substituting r and h, I can see that the volume of the cylinder, it's pi r square into h. That is equal to the total volume that you are going to make using that spherical bullets. That is 4 by 3 pi r cube into n. So we can see that here the radius of each bullet, we need to get that value. Diameter, it's given to be 1.5 centimeter. 1.5, you know, it is 3 by 2. So this is the diameter of this spherical bullet. So the radius will be how much? Half of diameter. That is half of 3 by 2. And that is equal to 3 by 4. Okay, so we can see here 4 by 3 into pi into r cube. That is 3 by 4 the whole cube into n number of bullets. It is equal to pi into r square into h. Is it clear to you? We can now cancel pi that is present on either side of the equation. And now from this, it is easy for me to get the value for n. Okay, that n, it is nothing but 28 into 6 square divided by 4 by 3 into 3 by 4 whole cube. That's all. So calculate this and now find out what is the value for n you are getting here. So could you please tell me how much it will come to? You do the calculation and get me what is the value for n. How many bullets you can make? That is the question. So tell me how much it comes to. Every inputs I have presented, quickly finish the calculation and let me know how much it comes to.
So is it 1792?
You are right. 1792. That is the answer. I assume this explanation, it is clear for you. 1792 bullets can be made. Okay. Let's now consider the next question. Question number 14. You can see that here you are considering 3 cubes. They are at just 3, 4 and 5 centimeters respectively. They are melted and they are recast into a single cube. So the volume of this big cube, considering the edge it's of some x units, the volume of this big cube, you know, it is equal to x cube. That is nothing but the total volume of the first cube, that is 3 cube, that is 27, plus the total volume of the second cube, that is 4 cube, that is 64, plus the total volume of the third cube, that is 5 cube, that is 125. Because here the total final volume is equal to sum of individual volumes, that is 27 plus 64 plus 125. And you know this value, it will come to 216. Thus I have x cube is equal to 216. This gives me x, it is equal to 6 centimeters. So this particular big cube, it has got an edge that is equal to 6 centimeters. So that brings conclusion to this next question here. Okay, 14th question here. Let us consider the next question now, 15th question. Read this question carefully and then I will explain the question for you. So please read it. So here, one main guiding formula that you have to note here is internal dimension. It is equal to external dimension minus 2 times thickness. Okay, this is the logic. So if you have, say, a square area like this, imagine, okay, a square area like this, say 10 meter, 10 meter like this, imagine. So the total area under consideration, if you have a look at it, the total area under consideration, can you tell me how much it will be? 10 meter into 10 meter you are considering. The total area, how much it will be? Yes, 10 into 10, that is 100 meters square, correct? Now imagine I am constructing a wall here like this. Okay, I am constructing somewhat a wall like this. Okay, so when I construct, this is the top view. Okay, so when I construct a wall, then you can see that there is an internal square that is coming up like this. Got it? Let me assume that this wall, it has got a thickness of say 1 meter. This wall, it has got a thickness of 1 meter. Got it? So I can see that the length inside this, which you calculate, can you tell me how much will be this internal length, what I have marked here? That is from this point to this point, how much it is? That will come to 8 meters. How did you get it as 8? You know that this internal dimension, that is equal to external dimension minus 2 times the thickness. This is the calculation that you are doing. Got it? So extending this across length, breadth as well as height, you will be able to handle this question. Okay. So you can see that here there is a closed wooden box measuring externally 9 centimeter, 7 centimeter, 6 centimeter. Okay, so I will consider it here length, then we have breadth, and then we have height, Okay, we can see that the external dimensions, it is 9 centimeter, 7 centimeter, 6 centimeter. Got it? The thickness, it's given to be half a centimeter. So now with this, I can find the internal dimensions of this wooden box. Can you tell me how much it will be? How much will be the length? Can you tell me?
Great.
It will be 8. 9 minus 1, 8. How about the breadth? How much will be the breadth? It will be 7 minus 2 times the thickness. So how much it comes to? It will come to 7 minus 1, 6 centimeters. And how about the height? Can you one of you quickly tell me? The external it is 6, half a centimeter thickness. So how much will be the height internally when you are considering? How much it will be?
5 centimeters.
Yes, corresponds to 5 centimeters. Now, the first question is, what is the capacity of the box? So capacity of the box means what? You need to focus on the internal volume, right? So that is nothing but 8 into 6 into 5. That much centimeter cube. 6 5s are 30, 30 into 8. You know it comes to 240 centimeter cube. This is the internal capacity of the box, and that is the capacity of the box as such. So for the first question, you got the answer as 240 centimeter cube. Got it? Now the next question, what is the weight of this box, supposing that 1 cubic centimeter of the wood, it weighs 0.9 gram. So as we have to consider that this box is empty and we need to only focus on the amount of wood that is being used here. So the amount of wood, if you want to find out, you just calculate what is the external volume. You find out what is the internal volume. If you subtract the internal volume from the external volume, the full volume, you will get the volume of the wood that is used. Okay, a little bit of imagination. If you make it, you can see if you separate that free space that is there inside that wooden box, if you remove it, then what you get is nothing but the volume of the wood that is used. So here you need to do the calculation as 9 into 7 into 6 minus 8 into 6 into 5. You have to do this calculation. So once you finish this calculation, you can see that this volume, it is corresponding to 138 centimeter cube. Is it clear to you? 138 centimeter cube. That is the amount of wood that is being used. Okay. Now, in the question, it is given 1 centimeter cube of this wood that is used. It corresponds to 0.9 gram. Okay. So 0.9 gram per centimeter cube of the wood. Like that, you are focusing on 138 centimeter cube of this wood. So what will be the total weight? It will be 138 into 0.9. And may I know how much will be the value? It comes to 124.2 grams. And that is the answer for our question. Is this explanation clear to you all? Any doubt? Okay. Let's go to the next question. Look at the next one. Here you are focusing on a cylinder which has got a radius. This radius, it is doubled. The height, it is halved. You're asked to find the ratio between the new volume and the previous volume. Can one of you please unmute and tell me what is the formula to find the volume of a cylinder? Volume of a cylinder is?
Pi r square h.
Pi r square h. So what I am going to do here is, I'm going to consider the radius, I'm going to consider the height, as follows. Okay, let me consider the original, okay, radius. Let it be equal to some 10 centimeters. The original height, let it be some 10 centimeters. So this gets me the original volume, that is equal to pi into r square, that is 10 square, into height, that is 10. This is the original volume. Okay. Now what is happening? You are changing the radius and the height. You can see that when you revise the radius, you can see that the radius, it is doubled. So now the radius, it is 20 centimeters, and the height, it is halved. The height now, it is half of 10, that is 5 centimeters. This revised volume, it is nothing but pi into 20 square into 5, pi r square h. Be careful here, you are asked to find the ratio between the revised volume, the new volume, and the previous volume. So you are asked to find what is the ratio here, pi into 20 square into 5 divided by pi into 10 square into 10. This is what we can see. Cancel the value pi here, and you can see that here 20 square by 10 square, if you consider, this value will be equal to 4. Okay, you can see that it goes here 2 times and this goes here 2 times. So finally it will come to 2 by 1. So the revised volume is to original volume. You can see that it comes to 2:1. And that will be the answer for our question here. All right. Now you can assume it to be like this, taking some values. It will help you to handle the information in a rather quick systematic way. If you want to go by R and H, very well you can, but just be careful when you are doing the calculations because you are dealing with pi, R, H, all variables and no numbers. So please be careful with that. Okay. Let us now go to the next question, that is question number 17. A conical vessel with internal radius 10 centimeter. So that is the radius. Height 48 centimeter. So we are talking about the vertical height here. Okay. This height, it is given to be 48 centimeters. All right. We can see that it is filled with water. So it is filled with water. So the volume of the water that is there inside this conical vessel, that corresponds to 1/3 pi r square h, that is 10 square into 48. So this is the volume of the water. Okay. Now this water, it is actually poured into the cylinder. You can see that this cylinder, it has got an internal radius of 20 centimeters, correct? So you can see that this volume of the water column that is now getting collected inside this cylinder, that corresponds to the volume of water that is there in this conical vessel. Thus, I can see that because you are pouring the water from this conical thing to the cylinder only. So imagine the cylinder was empty. So from the bottom, the water level, it increases and finally it reaches here. So this h centimeters is the water that is getting collected. So when I find the volume of water that is collected inside the cylinder, that is nothing but 1/3 pi into 10 square into 48. That is the logic. Okay. So we can see that here, these two volumes are going to be one and the same. 1/3 into pi into r square, 10 square into 48. That is equal to the volume of the water that is there inside the cylinder, that is pi into r square, that is 20 square into h. That h you are considering, that is the increase in that water level in that cylinder. Okay. So we can see this can be equated. Again, I can cancel pi that is there on either side of the equation. And this helps me to quickly get the value for h. H, it will come to 10 square into 48 divided by 3 into 20 square. So you know this comes 4 times. And you can see that here 12 fours are 48. And this 3 goes in 12. How many times? 4 times. And that gets you h. It is equal to 4 centimeters. Upon calculation, I am getting the value for this h here as 4 centimeters. And that is the answer for our question. All right. Now let us consider the next question. You are asked to find the area and then you are asked to find the cost of whitewashing this much area. Okay. So study this carefully. We can see that here the area associated with this side, what I am shading now, as you all can see. Can you tell me what will be the area associated with this yellow colored square here? You know the length, it is equal to 3 and the breadth, it is equal to 2.5. Got it? So you can see this comes to 3 into 2.5. Correct? No? So what is 3 into 2.5? That is equal to 7.5. It is given in meters. Okay, so meter square. I can see that exactly opposite to this square, there will be another square. It's actually not a square. It's looking like a square. So you can see that exactly opposite to this side, there will be another side that is located. Okay, another area that is located. And that area also will be 7.5 meter square. Don't you agree with me? The 7.5 meter square here and at the back side. Both are the equal values here. So 7.5 plus 7.5 consider. Now let us focus on the next area here. Okay, this red colored one. Can you tell me what is the total area that I can consider here, which is painted with this red color on this side only? How much it will come to?
10 meters square.
4 into 2.5. That is equal to 10 meter square. As you correctly said, this value will come to 10 meter square. But again, to this particular surface, opposite to that, there will be another 10 meter square that can also be considered now. So I have considered two such areas. Now I want you all to focus on this roof. Okay. So don't mistake that this is a parallelogram. This is actually the side view. So you can see that this is nothing but a rectangle. Okay. Don't you agree with me? What you see here is actually a rectangle. Okay. So can you tell me what is the area of this rectangle, the roof? That comes to be equal to, you can see this is equal to 4 meters and into 2.5, 4 into 2.5, you again have a 10 meter square area. But that is this side, and over here also you can consider a 10 meter square area. So 10 meter square and 10 meter square. You can consider two such areas. All right. Now, what is left out? Can anyone tell me what is left out here? The area pertaining to this triangular region. So you can see the base length. If you consider for this triangle, you can see the base length, that is from this point to this point. The base length, if you consider, it is 3 meters. Can anyone tell me what is the height of this triangle by observing this 1 meter? So I can see that the area of one triangle here, it is nothing but half into base into height. But I can see that there is a triangle this side and there will be a triangle this side as well. So two triangles can be considered. So the total area pertaining to these two triangles, that comes to 3 meters square. Got it? So now I want you all to add all these areas together. So quickly add all these areas together. So how much it comes to? 10, 20, 30, 40, 55 plus 3, 58. 58 meters square meter. Correct, no? So that is what the total area considering all these shapes here. But in the question it is given in this 58 meter square, 18 meter square, it goes towards windows and doors. We won't be painting the windows and doors, or we won't be whitewashing the windows and doors. So exclude that 18 meter square from this 58 meter square. So can you tell me what is the effective area to be whitewashed? That comes to 58 minus 80. That comes to 40 meter square. Correct? Now, the cost per meter square, the cost is 1 rupee. Like that, you have to focus on 40 meter square. So can you tell me what will be the total cost? It is rupee 1 per square meter. Like that, you are focusing on 40 meter square area. So can you tell me what will be the total cost now? That corresponds to rupees 40. And that is the answer for our question here. All right. Now let us focus on the next question. You are asked to find what is the area of this given figure. Okay. So you can see that here there is a semicircle that is present. This semicircle, it has got a radius of 14 units. So this semicircular area, if you consider, that will be half pi r square. So half of pi into 14 square. Okay, because full circle, the radius is 40. So the full circle has got the area pi r square, but you are focusing only on the semicircular region here. So this much area, if you calculate, that comes to half of pi into 14 square. Now, I want you to focus on this small lobe that is presented. Can you tell me what will be the radius associated with that small lobe? Can you tell me how much it will be?
7.
7 units. So it is also a semicircle. Okay, so you can see that this area will be half of pi into r dash square. Okay, that is 7 square. Now, if you are going to add these two areas that you have calculated, that is going to get you the final answer. Okay, so half of pi, I can take out the common factor, find out what is this 14 square plus 7 square. And simplifying this, you will be getting the answer. And may I know how much will be the answer it comes to? Quickly do this. Half of pi into 14 square plus 17, sorry, 14 square plus 7 square you can do. Quickly get me the answer. You can take the value for pi as 22 by 7. Okay. So now quickly tell me how much it comes to.
462.
I think you have to verify the calculation. Is it 462? I have it out. Half of 22 by 7 into, we have 196 plus 49.
385.
Yes, you should be getting it as 385, right? 385 units square or square units. Okay, square unit. 385, right? Okay. So that is for this question. And now comes the final question for our today's discussion. You can see that there is a cylindrical tub. It has got a radius of 12 centimeter. It contains some water. To this cylindrical tub, you are putting a spherical ball, dropping a spherical ball, and thus the water level, it is raised by 6.7 centimeter. You are asked to find the radius of the ball. So you can see that the increase in the height of this water, that is nothing but the volume of this spherical ball. So volume of the spherical ball, it is 4 by 3 pi r cube, assuming r to be the radius of the ball. We can see that 4 by 3 pi r cube, that is the volume of this ball. You are dropping it into this cylindrical tub. So because of this presence of the spherical ball, the height of the water level inside that cylindrical tub, it has increased. So the volume corresponding to that increase, it is nothing but pi into r square. The radius it is given to be 12 centimeters. So 12 square into height. You can see that height, it is not the 20 centimeter you should focus, but you can focus on the 6.75 centimeter. The increase in the height of this water level, it is in proportion to the volume of the item that is dropped into it. Okay, so using this result, now I can cancel the value associated with this pi, and that gets me r cube. It is equal to 12 into 12 into 6.75. Okay, into, I can say that it will be 3 upon 4. And by taking the cube root of this expression, I can get the value for r. So r is nothing but cube root of this given expression. Okay, so can I know how much will be the final value that you are going to get for this r? Could you please do it for me and tell me how much you are going to get for this r? Okay, and this is the final question that we are officially discussing. So kindly let me know how much you are going to get here. Okay. Okay, I can see that here 12 into 6.75 into 3 upon 4 r cube. This value will come to 729, and that fetches r. It is equal to 9. Everything is given in centimeters, so 9 centimeters. So this spherical ball, it has got a radius of meters. All right. So with this question, we have reached the end of our discussion pertaining to solids. I hope that you have followed this discussion clearly. And with this, we are concluding this session as well. So thank you very much.